Welcome to Algebra, Chapter 6, Section 1, Solving Systems of Equations by Graphing. We have two major goals. One is to be able to solve a system of linear equations by graphing. And two, to identify a system of equations with one solution, no solution, and infinitely many solutions. Take a moment and write I if the amount described is infinite and F if it is finite. Let's see how you did. Rational numbers greater than 6 is infinite. Numbers of seats in a movie theater is finite. The numbers of grams in 1 kilogram is infinite. And the set of odd numbers is infinite. Now give one example of an infinite amount. Explain why the amount is infinite. An example of this is a set of all positive numbers. Again, there are many possible examples. Feel free to question me on this tomorrow if you need help. So what is a system of linear equations? Well, quite simply, it's two or more linear equations given at the same time. So what's a solution of a system of linear equations? Well, it's the ordered pair that makes all of the equations true. So if we're looking at this system of linear equations, I know that 0, 1 is a solution because it makes both of them true. I can do 1 equals 4 times 0 plus 1, and that's a true statement. And I can do 1 equals negative 3 times 0 plus 1. And as you see, the point 0, 1 makes both of these a true statement. Looking at the point 2,9, it does not make it a true statement. Although it is a solution of y equals 4x plus 1, it's not a solution of the second equation. So it's not a solution of the system. So how can we find solutions? Well, there are three common methods. The first method is graphing, which we're going to talk about today. The second method is substitution, which we'll be discussing tomorrow or the next day, depending on how this goes. And the third method is elimination, which we will discuss after substitution. When you solve by graphing, you simply graph both equations and find the intersection. In this case, our intersection is 1, 3. The guide, I've listed the steps here. Step 1, put each equation in slope-intercept form. Why do we do that? Well, that's the easiest form to graph. If you remember, that's the form y equals mx plus b, where b is the y-intercept and m is the slope. Once we get there, we go ahead and we graph each equation, and then we find the point of intersection. Then the last step is to check and make sure it is the solution to both equations. So to make sure that it makes both equations true. Through the steps of solving the system of equations by graphing. Looking at this, you see that the first equation has already in slope-intercept form, and its y-intercept is 4. Now from 4, it has a slope of 2. So we're going to rise 2 and run 1. I can also do negative 2, negative 1. So this will be my line. Let's look at the next line. This one has a y-intercept of 2. So I'm going to put a dot on 2. And then it has a slope of 1. So it's rises 1, runs 1, or rises negative 1, runs a negative 1. So here's going to be its line. And as you can see, right here is where it crosses. So it crosses at negative 2, 0. Now to check and make sure this is true, we're going to put 0 in for y, and we're going to put negative 2 in for x. As you know, 2 times negative 2 is negative 4. So it is true for the first equation. For the second equation, we're going to do the same thing. 0 in for y, -2 in for x, and it's true. So we've proven that our solution is -2, 0. Let's go ahead and try another example. The first step is to put each equation in slope-intercept form. As you can see, the first equation is already in y equals mx plus b form, so we're set. But the second is not. It's in standard form. So let's add x to both sides to isolate the y. We get y equals x minus 1. So now both equations are in slope-intercept form. Next, we take each equation and we graph it using our y-intercept and our slope. So looking at the first equation, we have a y-intercept of -3 and a slope of 2. So rise 2, run 1, rise 2, run 1, rise 2, run 1. And drop 2, -1, drop 2, -1. And for the second equation, you see it has a y-intercept of -1 and its slope is 1. So rise 1, run 1. Now I'm putting a lot of points in here because it helps make my line straight. And as you can see, we find the point of intersection, and the point of intersection is right here, and that is the point x value 2, y value 1. So it's the point 2, 1. For example, I would like you to stop the video, go to the next slide, and solve this on your own, and then check back with the video. When you're ready to go on, just press play, and I will show you how to work this problem. Work this problem out just like you should have. Let me go through the steps that I did. Looking at the first equation, I noticed it's already in slope-intercept form. So using my intercept of -4 and my slope of 1, rise 1, run 1, rise 1, run 1, I created this blue line. Then I looked at my second equation and noticed it was in standard form, not slope-intercept. So I isolated the y to get it in slope-intercept form, and realizing that y equal -x, my y-intercept needed to be 0. So I plotted 0, and then my slope is a -1. So I down 1, run 1, down 1, run 1, down 1, run 1, and made my line. By graphing these, I noticed they crossed at the point 2, -2. Taking that point, I put it into both equations and saw that it is truly the solution to both equations. Now I need to bring up the one warning when using graphing as a method to solving systems of equations. Your graph needs to be accurate, it needs to be carefully drawn, and this method works really well when the answer is in whole numbers or integers. When it's not in integers and it's in fraction form or rational numbers, it becomes a lot harder to determine where exactly those two lines are crossing. A system of equations has at least one solution, at least one, so it could have more. It's consistent. A consistent system can either be independent or dependent. A consistent system, A system of equations that has at least one solution, at least one, so it could have more, is consistent. A consistent system can be either independent or dependent. A consistent system that is independent is the one that has exactly one solution, whereas a dependent system has infinitely many solutions. So independent is one, dependent is infinite. If the system of equations has no solution, it's inconsistent. So let's underline the correct word, words, or number to complete each sentence. If two lines intersect at one point, that means they have different slopes, and they're connecting at one point, the system of equations is independent and, that's correct, consistent, because inconsistent is when it has no solution. And if it connects at one point, it has one solution. If two lines are the same, exact same lines, so they have the same slope and same y-intercept. That means they're the same line. The system of equations is dependent. Well, if it's dependent, it's still consistent. And the system of equations has infinitely many solutions. Since they're the same line, all of the points will solve both equations. Now, if the lines are parallel, which means they have the same slope but different y-intercepts, they never cross. Since they never cross, they're inconsistent because they have no points in common. And that means they have no points in common, which means they have zero solutions. Let's take a look at the next problem. We have a system of equations. Looking at the system of equations, we see that they have a different y-intercept, a different b. But we see that their slope is the same. They both have a slope of -1. Since they both have a negative slope, the only graph here that has two lines that are both negative slope is b. And the slope's the same, so we know they never cross. That means the lines are parallel. And since parallel lines never cross, there is no solution. If you have trouble with this concept, make sure you put a question mark by this and talk to me in class tomorrow. So to restate, a system of linear equations has no solutions when the graphs of the equations are parallel. So if the lines are parallel, there are no solutions. And a system of linear equations has infinitely many solutions when they're the same line. So if you see it's parallel and it has the same y-intercept, you know it's the same line and the solutions are infinite. That's the end of the video for today. Do the lesson check in the math success, telling me how well you can solve a system of linear equations, and I will see you in class tomorrow.